So finding trig values. Now, this is actually something that we have done before. We would have done it back in September in the first 3 weeks of school. It's all right if you don't remember that, but sometimes as we go through this lesson, people will be like, kind of looks familiar. It's just that we're doing it in a different way. We're doing this with the identities. Okay, now finding a trig value is a matter of, let me put this up here. It's a matter of picking the right trig identity, as I say here, selecting the right trig identity that's going to use the given value and the desired value. And we're trying to emphasize those two phrases, the given value and the desired value. What does this mean? I hope that in practice you'll find that you understand how to select the given and the desired. Okay, and obviously let's show you what that means as we work through a couple examples. Let's do a consider, because that means that maybe there's something you understand already, and maybe there's something new here. All right, what we have is a classic statement about trig values. First, if you're just kind of wondering, like, what kind of problem is this? Well, it's a problem where I give you a trig value. So I give you the secant equaling 7/2. Okay, so I'm giving you that the secant equals 7/2, and we want to find the cosine. One thing that's important just to understand, even if you're not totally sure where this is going, we're not trying to find theta. Sometimes people try to do a little too much, even on their calculator, like try to figure out that theta equals 30 degrees or something like that. We're never going to be finding the angle. What we're actually trying to find is the cosine of the angle. Okay, now to do this, we have to first realize that this is the given value. So we've been given secant. It's pretty evident. We've been given secant. We're trying to find cosine. Okay, that's the desired value. Now, in your identity book, and you actually want to look in it, you want to find a identity that uses secant and cosine. Are you tracking with me? You want to find an identity that uses secant and cosine. Okay, now you don't have to look too far. Probably the way that you wrote your book, you wouldn't have to look too far, like only page 1. And you should find an identity that uses secant and cosine. Okay, sometimes this one's, I don't want to say it's too easy, but we're going to have to select, there's no other option, the one that says that cosine is equal to 1 over secant. That's the identity that uses secant and cosine. Now you can see that I use that version because it's the one that's already equal to cosine. So if I'm trying to find cosine, let's pick the one that's already equal to cosine. All right, so we select that identity. Now, after you select it, all you got to do is plug in. Now, carefully, but you have to plug in what you've been given. Okay, now 7/2 is what I've been given, so I want to plug that in. But I want you to watch carefully as I plug it in for secant. I'm plugging 7/2 in for secant. Now, the reason I'm just kind of going slowly here is that I want you to notice that I didn't plug in 7/2 for theta. It actually doesn't really make sense because we don't know that what theta is. So I'm not plugging 7/2 in for theta right here. I'm actually plugging in for the whole secant because the whole secant equals 7/2. What is this? What is 1 over 7/2? Don't punch it in your calculator. Just do a little thinking with me. It really means 1 divided by 7/2. Now, 1 divided by 7/2, we've even talked about this a little bit this year, but other years you should have learned that to divide by a fraction is the same as multiplying by its reciprocal. So basically 1 divided by 7/2 is the same as 1 times 2/7. And of course, 1 times 2/7 is 2/7. Now, if you look at what just happened here, you would come up with hopefully a simple conclusion, and that is that we have the reciprocal. I mean, quite honestly, we started with 7/2, and now we have 2/7. We have the reciprocal. That's because secant and cosine are reciprocals. Okay, do we show a little bit of work? Yeah. Do I want you to show that work? Yeah, because I'm trying to get you to understand the identities. Okay, but bottom line, we have a reciprocal. Let's try another one that is purposely a little bit different, yet it still follows this strategy. The strategy is to try to select an identity. Same thing. Let's just kind of consider this. This time we're going to say that the sine of theta, which is given to us, is equal to 5/7. Now we want to find the cosine of theta. Sine of theta is 5/7. We want to find the cosine. Remember how the method is to look in your identity book to select an identity that uses, well, for this problem, that uses sine and cosine. Now think about that. You want to pick an identity that uses sine and cosine. It can't use more than sine and cosine, and it can't use less than sine and cosine. It has to use just sine and cosine. You should be looking past page 1 and past page 2. You should be in the center of the book. What do you see? Beautiful identity. Sine squared plus cosine squared equals 1. Yes, 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 we should use it. So we select it, we use it. You can skip showing this if you want to. I'm just showing it for the notes so you get the idea of how we're starting. Because now what you want to do is you want to carefully plug in. You want to plug in 5/7. Now, when you plug in 5/7, okay, it's a little different than what you did last night on your homework. 5/7 is not the angle. You're not plugging 5/7 in for theta. It's not an angle. It's actually the sine. In other words, it's now 5/7 that's being squared. And I just want you to look real carefully how I wrote that. See what I did? I substituted 5/7 in for sine. But now it's 5/7 that's being squared. This is sometimes the step that is missed by students, that is the square. Okay? You have to square it because that's part of the identity. We have a little bit of algebra to do here. Okay, this is like the algebra chapter, so it's time to square 5/7. Now, before you get your calculator out, you should be able to square the numerator and the denominator, and I'm going to encourage you to just square it physically and get 25 over 49. It's actually going to be better than using your calculator and getting some kind of decimal. Now, as you look at what's on the board here, you should feel like it's an equation. And you guys have been around equations. That's why you're sitting in this class. You're trying to solve this equation for cosine. So what I'm saying is you're allowed to do equation stuff. If I'm trying to solve this for cosine, then equation stuff would be like subtracting 25 49s from both sides. Sure, I'm allowed to subtract things, move them around. We call it inverse operations. So I'm subtracting that from both sides. Now, when you do that, you once again get something that needs to be calculated. You get 1 minus 25 49ths. Before you get your calculator out, it's going to be better for you guys to calculate that using a common denominator. Now, listen, the denominator is 49 on this one. Right now, the denominator on this one is 1. To make them common, I need this one to become a 49. Now, I can make this become a 49 if I just write 49, but really what I also need to do is multiply the top by 49. 49 over 49. It's the new way to think of the number 1 for this problem. Okay, so that I can subtract 49 minus 25. Okay, you subtract the numerators. Please don't subtract the denominators. That's the whole idea with common denominators. You keep it common. 24 over 49. We're solving for cosine. Almost there. We're solving for cosine. You have to get rid of the square. Now, that would mean that you want to take the square root of both sides. Again, good algebra. The square root of 24 over 49, again, before you get your calculator out. Now, if you're saying, I can't use my calculator at all, I'm trying to show you that we want to give the answer. We want to give the answer as a fraction. So there's some stuff that I'm doing here, like keeping these numbers in the fraction, like keeping root 24, keeping 7. I want to see those numbers. Now, root 24, it is the highway that connects Stewartstown with Red Lion. It's also a square root that needs to be simplified, root 24. Okay, there's a perfect number inside of 24. Sometimes this pops up and you have to just be ready. Are you thinking of two numbers inside of 24? One of them is perfect. It's a 4 and a 6. The 4 comes out as a 2. The 6 stays behind. We get 2 root 6 over 7. Now, there was some extra stuff at the end of that problem, but we now have cosine. Cosine, 2 root 6 over 7. Maybe. Okay, it's definitely a possibility. Thanks for kind of being aware of that. Here, the denominator worked out nicely to be 7, so we didn't have to mess with it. I want to give you a problem to try. Actually, kind of want to give you 2 problems to try. Let's see here what would be helpful. Why don't you guys spend a little bit of time thinking about both of these. Okay, here we have tangent equaling 4/5, and we want to try to find the cotangent. And here we have tangent equaling 2/5, and I want you to try to find the cosine. So we've got a couple tangent problems, but we're not really off on a tangent. We're just giving you those 2 functions. just to try to provide you a little feedback, especially if you're stuck. This would be your best option. This would be your best option. Now, if you use the other version of it, where like cotangent and tangent are switched, it'll still work, but this is easier because it's already solved for cotangent.
So I got the book we made.
Good. Sure. The book is just, if people want it. If you ever want to make one, but you know, it's not like you have to turn it in or something. It's for you guys. Again, just to give you some feedback, I see a lot of good answers for this, which is great. You basically are going to plug in 4/5, and as you hopefully remember from the first problem we did, 1 over 4/5 is eventually just going to become 5/4. Okay, it's a reciprocal problem. It's supposed to be pretty easy, but I still want you to show that you plugged in 4/5. You did the reciprocal, and now you have 5/4. How's the second one going? Are you finding an identity that uses tangent and cosine? You wrote the book. Do you know what you wrote? I'm joking a little bit, but you wrote the book. Do you know what's in there? Tangent and cosine. Now, if you're like, Miss Naylor, I'm not finding it. Well, I would say at this point, you're right. There's not one that uses tangent and cosine. Now, if you're like, yeah, I saw one that used tangent, sine, and cosine. Okay, but I don't want to use the one that uses sine because I just want tangent and cosine. So I can't use the one that has that sine in there. Does that mean we can't do the problem? Not too many things like that this year. There's not too many where it's like, yeah, you just can't do it. Tangent and secant? The answer is yes. How could we use one that uses tangent and secant? Do you realize that cosine is really just a secant in disguise? Cosine is really one step away from secant. To try to help you guys understand, if we can find secant, now just listen to this carefully. If we can find secant, well, we're only a reciprocal away from cosine. So, are you ready to find secant? Okay, that's the idea here. We're going to find secant. Now, I kind of want you to do the problem, so, you know, however much input you'd like to put here, but let's make sure that we're picking the right identity. Okay, tangent squared plus 1 equals secant squared. So again, we're gonna sort of through the back door, we're gonna find secant, but then we'll have to figure out cosine before it's all over. Do you want to try to plug in to tangent squared plus 1 equals secant squared? You're just plugging in 2/5. Same thing, I just want to be a step behind you. I want you to try to do this, but if you're making a mistake or if you're just not sure how to continue, you can take a look up here. I'm just plugging in 2/5. So now we have 2/5 squared plus 1 equals secant squared. Careful, I've taught this to kids before. I just know sometimes we forget the square. Okay, don't forget the square. Like right now, you should be squaring 2/5 to be 4/25. That's really important. 4/25. Don't forget the square. Are you trying to add 1? Are you trying to add with a common denominator? 25/25. I really don't want you to get too calculator dependent. You want to think about adding 25 plus 4 to be 29/25. 29/25. 29/25. Okay, just like the other problem we did, you do have to take a square root. It's very common. It's very common to take a square root, and we get the square root of 29, and we get the square root of 25. Now, the square root of 29 is root 29, but the square root of 25 is 5. We're like one step away. Just giving you guys a chance to make sure you're okay. Are you thinking, remember, we want to find cosine. We're one reciprocal from cosine. We're one reciprocal. Now, I'm going to give you permission to just kind of do the reciprocal. You don't have to try to like plug into another identity. As long as you understand that when you do the reciprocal of secant, well, you're getting cosine. And as long as you understand that you have to do the reciprocal of this fraction. So now I have 5/root 29. I think a little birdie said that you can't have a square root in the denominator. Okay, so yeah, this problem kind of has that extra step where I got to clean up this square root. Kind of seems like a pain, but it's the way it goes. It's square root up to the top, and it's a regular 29 in the bottom. Now, that problem certainly had some extra things going on, but I want you to see that in class. That's our final answer, 5/root 29/29. Just go back to the beginning of the problem with me one more time. We had tangent and cosine. You look in your book, there's no tangent and cosine, but there is a tangent and a secant. So we're going to have to choose that one so that we can then fix our answer. We can change our answer to be a cosine. All right, a little different. Honestly, every day is going to be a little different. We're showing you guys the algebra side of trigonometry. Try the homework helper. All right, and have a good day. We have that extra period today, don't forget. Hello, sir. Most of the notes are up there. I did erase some. Of course, it was all recorded.